Okay, good day, class. So, we'll perform experiment number 2, entitled Vernier Calipers. No? So, in this experiment, the objective here is to study the Vernier principle and to use a Vernier caliper in the measurement of various dimensions. Now, in this activity, we use here a Vernier caliper, cylinder, the cylindrical cup, and of course you have here a measuring tape, and you have here a what we call a glass plate, no? A glass plate. So what we'll do here is to determine the inner, and of course we still also have the weighing scale. No? Now what we have here is to measure the inner diameter of this cylinder, this cylindrical cup, and the dip, no? And the dip of the cylindrical cup using the Vernier. So how do we use the cylinder? Since there are two different jaws in this cylinder, this jaw here can measure the outer diameter of the cylinder. This jaw here measures the inner diameter of the cylinder. So since we are to measure the inner diameter, so we use this jaw, no? Okay. So here we can read the inner diameter of this cylindrical cup, okay? And after that, we record this as in centimeter. Okay. You also have the table at the back, pages of the manual. So we read the inner diameter of this cup as 1.730 centimeters. No, this is the inner diameter of the cup. Now we will measure also the depth, okay, using the extension arm of the Vernier. So this is the extension arm of the Vernier caliper here, no? So whatever this extension arm extends, it can be read on the Vernier here. We can read that. So this reading here equivalent to that extension of its arm, no? So here, when you read the depth of this, just simply put inside the extension arm, okay, up to the bottom, no? Okay. Okay, so this is now this is now the depth of the okay, so this is now the dip, no? And we can read this as okay, so the reading there is 9.960 centimeter. So this is now the reading of the depth of this cylinder, no? Why we measure the diameter and the depth? Because we are to determine the inside volume of this cylindrical cap. Because you have the diameter and the height or the depth of the cylinder, then you can measure the volume. Okay? So after knowing the diameter of this and the depth or the the depth of this cylinder, we have to weigh this one using the weighing scale. Okay. Why we weigh this one? Because we will fill this cylindrical cup with water, no? So we are using this weighing scale. So it reads as 47.4 47.3 grams, no? You have 40 plus 7 plus 0.3, so 47.3 grams. So this is the mass, no? This is the mass of the cup, no? So after that, we fill this with water, no? So that we can measure the mass. So we will this again because it is already filled with water. Okay. So with water, the reading now is 71.5, no? So with water, the mass is 71.5 grams. So why we weigh this with water? Because we are to determine the mass of the water. So therefore, if we subtract the mass of the cylinder with water with the mass of the cylinder, the empty cylinder, so it comes out that the mass of the water inside the cylinder is 24.2 grams. So this is the mass of the water, no? This is the mass of the water in cylinder. Okay, so we have here the data on with respect to the cylindrical cup, no? So here you have to calculate here the density of water, no? Using the data, no? So likewise, you have to compare the diameter of the cylindrical cup in inches, no? In inches also, just like my illustration earlier, no? On how to read, no? So what we have what we have taken are the diameters and depth of the cup in centimeters. Okay, so